Okay, welcome to some new slides. These are on files and streams, and these will be a nice breath of fresh air in between a bunch of hard topics. Like classes were hard, pointers were hard, files are super easy, so let us look forward to them. So let's begin, and let me teach you how to write to files. Okay? So right now, what you know how to do if you want to give information back to the user is to use cout, right? You say cout something, cout 42, and then 42 magically appears on the terminal screen, right? That's how we give information back to the user. There's more to it than that, right? We can also maybe make a new file and write to that so that the user can go and look at it later, open it in Vim or Nano or something. So there is, instead of cout, there's a type called ofstream that writes to a file. So what you do is you create an ofstream object that represents that file that you want to write to, and then you can use it to write. Okay? So ofstream, that type, it first of all stands for output file stream. Output file stream, and it lives in the library called Fstream. Okay? And so what you're going to eventually do is make an ofstream object. I'll call it like OFS or OS. OFS is good. And you're going to open a file with it. I'll show you how to do that later. And then if you want to give information to it, as if you were going to write to the file, you use it just like cout. You use that same operator to give it to OFS, your ofstream object, and it really does write it to the file. Okay? So that is how ofstreams are supposed to work. So I guess here's the library, first of all. Here's the Fstream library, and we can go into it and look at ofstream, wherever that is. Oh, I didn't go to the library, sorry. There's the library, and here's ofstream. It stands for output file stream, and here's all the operations you can do on an ofstream, one of which is write to it, put stuff into it. It's called insert formatted output. Okay? So there's a lot more to talk about, and I'll show it to you. So let us begin. First example, let's write the numbers 1 to 10 into a file. All right? So we need that Fstream library, and we're going to make an ofstream object and start writing to it. So we're going to eventually write to a file. Let's call it like 1 to 10.txt. And the contents of that file, if we were to open it after we ran our program that wrote to it, would be 1, 2, 3, 4, all the way down to 10. Okay? So it's like we're printing 1 to 10 not to the terminal, but to a file. How cool. So yeah, let me show you how to get started there. So I guess we'll just call it 1 to 10.cpp. And so here's how you do it. Include ofstream, or sorry, just Fstream. And then we're going to make an ofstream object. Okay? That's defined in the library. My default name is OFS. And so that is an object capable of writing to a file. We have to tell it what file to write to now. Okay? So you can do it in one of two ways. You can do it with a constructor. There's a constructor to ofstreams where you just give the name of the file as a string. Like 1 to 10.cpp, or sorry, txt. That's one way to do it. Or, alternative, you just do it the normal way, declare it, and then you open it. You say ofs.open the name of the file you want to write to. Okay, so let's do it this way. And open is another method. So we can go to there, it's like open. Opens a file, takes a string to the file name. There's an example of it, for example. And that is how open works. You just give it the name of the file you want to open, and then it'll create it if it doesn't exist, or overwrite it if it already does exist. Okay? So, yeah, we've opened the file, and now it's ready to be written to. So now we write to the file object, and we pretend that it was cout so that we can use our cool less than operators as we do. All right, so let's write 1 to 10 to the file instead of cout. Right? So the whole syntax is exactly the same as if we were couting, right? If I were to cout all the numbers from 1 to 10, I'd say cout I and L. but I want to write to the file instead. I want to go into the OFS object. Okay, that's all. So at that point, I've finished writing all the things I wanted to write to the file. Got the numbers 1 to 10. And now always a good thing to do once you're done with a file that you have open is to close it also. Okay, so there's a .close method that you should use to that you should remember to use to make sure the file is closed the second we don't need it anymore. Technically, the file will get closed as the program ends or as the scope ends, but it's good practice to remember to close the file when you're done with it. Okay, so that is the nice standard way of doing this. And let's run it. So I have the CPP file, this program, and also the compiled version of the program in my current directory. So if I run the compiled program, what it's going to do is it's going to make a file called 1to10.txt if it doesn't exist, and write to it. Okay? So look at that. There it is. So now I can open it. There it is. And here is a file with 1 to 10 in it. Oops. How cool is that? So that is exactly what we just did. We wrote a CPP file that wrote to another file, and now it's all pretty exactly how we wanted it to be. Okay? So that was 1 to 10. Yeah, I just want to reiterate this. It is a good idea to close a file, even though it'll be closed for you at the end of the scope, and by that I mean the nearest closing brace. Yeah? So that's important. Alright, let's keep going, because there's different kinds of outputting. So let's say I rerun this program, rerun the 1 to 10 program. There are two options for what it could do, right? 1 to 10, enter. It could keep writing, it could write 1 to 10 one more time in this file because it already exists, but it does not. It just overwrites the file with the new stuff, okay? So rerunning the program, rewrites the file, it overwrites it, okay? Keeps replacing it. So sometimes you want to keep adding to an existing file. So the term for that is appending. You're appending to the end of a file, okay? And that is the goal here. So let's figure out how to do it that way. How do we append so that when we already have a file that looks like 1, 2, all the way to 10, how can we open it up again? It's already got 1 to 10 in it. How can we open it up again and maybe add 11 or something? Okay? Starting here, like start here, add more stuff. So let's open our file in what's called Append Mode. Okay? And so this is an extra parameter to the open method. So open secretly takes 2 parameters, but the second one has a default value that you don't always need to give. The default value is just replace the file. We want to give a different value to the mode in which we open the file. We want to open it in append mode. Alright, so here is how we're going to do it. We'll say OFS dot open with the name of the file as usual. And then we're going to say this, iOS base, it's a weird constant, iOS underscore base, colon, app for append. Alright, so that is how we're going to open our file in append mode. And now if we write to it as we did before, it will just add stuff. Okay? Oops. Boop. Alright, let's steal a lot of this, and let's open up a new file called append.cpp. So, here's my OFS. I'm going to open it in iOS base app mode. That's append mode. And now if I write to it, maybe I'll write, I don't know, let's just write 11, why not? OFS, please take the number 11 and a new line. And then close the file as normal. So we've opened it up in append mode now. And then we wrote to it. So if I run the program now, boop, so it was this. If I run it once, boop, and reload the file, now it has another line with 11 in it. If I run the file again, or run the program again, it just keeps on appending that new thing to the end of the file. So it's going to add 11 as many times as I run it. Yeah, that is the idea. So we're just appending one at a time. Oops, there's this. Keep on adding 11. All right, hopefully that makes sense. So let's go a bit deeper now into these types. Like, why in the world is like OFS working like cout in a sense? It takes that same operator. Why do they seem a bit similar, right? They're both outputting information. What's going on there? So let me tell this to you. Let me show you what cout is. I haven't ever told you what the type of cout is, have I? But you can look at that. You can go to IOStream. You can go here. You can click cout, and here is how it was declared. Forget about the extern, but the type of cout is called ostream. That's very close to ofstream, isn't it? Let me show you something, in fact. Here is ofstream. It's related to the ostream type. It's related to the iOS type. It's related to the iOS base type in a certain way. So, yeah, that's interesting, isn't it? So cout's type is an ostream. And an ofstream is also an ostream. All right, it's called inheritance. Ostream is just another type, and ofstream inherits from ostream in this way. Like, it takes some of its qualities. We won't talk about inheritance in this class, but I think you can get a bit of an idea of it. Ofstream inherits from ostream. It's like a more basic type, and it takes all of its qualities. And because they are related, because ostream, cout's type, and ofstream, which inherits from ostream, because they have those related types, they work similarly. That's why they have similar sounding operations, like that operator less than. Okay? So I'm not going to test you on any of this, but in case you cared, this is why they're treated the same. Cout, OFS, because they're both ostreams. Okay? So you can actually do cool stuff with that. Because you know the types of things and how they're related, you can write a function that takes not an ofstream, that takes not cout, but takes any ostream object, because that's a similar type that they share. You can write a function that just takes an ostream and writes just as easily to either cout, if you pass in cout, because the type of cout is ostream, or to a file, because the type of ofstream involves ostream. You can replace it with that. How cool is that? So let's go and make this function maybe. Void write 1 to 10 with any ostream, right? And you can just say, where OS is your ostream inside of the function body, you can give stuff to it using that operator that we know cout and ofstream share, and it will write to whatever ostream you gave it, either the file or cout. How cool is that? So yeah, you could run it this way. Write 1 to 10 OFS, because OFS is an ostream, or you can write 1 to 10 with cout. You can give cout to a function, because why not? And cout is an ostream, and it will just, well, it'll write to the terminal at that point. Crazy. So let's do that. Let's copy most of this then. Ostreams.cpp. So here is, or let's do it this way. So instead of all of this, this is the common stuff, right? That's all the common things. So let's replace that up with the stuff up here. So let's write our void write 1 to 10. And it's going to take an ostream by reference. We don't want to copy anything. So this cannot just be changed to this, where OS is the name of our ostream object. And now we're off to the races, because I can call this function like this. I can say write 1 to 10. Let's do 1 to 10, I don't know, -2 or something, to have another file to work with and look at. Write 1 to 10. All right, I guess we can use the same one, why not? It'll just overwrite it. So I can give OFS here, and so it'll take the OFS and write to it, because that'll be OS. Or I could say write 1 to 10 with cout, and it will just as easily write to cout, because OS will be replaced with cout at that point. So I can both write to a file and cout in a similar way by using their shared type. I hope that makes sense. Please yell at me if it does not. Oops. And so, if I run this, let me go back to this file, 1to10.txt, because we're about to replace it. Boop. So, look at me reload the file, and it has 1 to 10. And also, look what got printed to the terminal, because I ran that function with 2 different kinds of arguments. Where did it go? Here it is. I ran it with OFS, so write to OFS, and I ran it with cout, so write to cout. OS gets a chance at being both of those. That's super sweet. So that is writing 2 things where those things have similar types. And so I think now you're an expert at writing files. Let's talk about reading them, because that's, I guess I would say it's slightly different, maybe slightly more complicated, so that's why we're talking about it next. But it is really just the analog of cin. Instead of OFstream for output file stream, I'm sure you can guess that it's going to be IFstream for input file stream. That's how we're going to read files. We're going to take them as input. Okay? So yeah, IFstream stands for input file stream. And just like before for OF streams, where we had one other way of getting output to the user, where we were putting stuff on the terminal, let's think about all the ways that we know how to get input right now from the user. We can use cin to ask the user, as the program's running, what they want to type. We can also use getLine, but it's using cin anyway, so maybe that's the same thing. So yeah, we can get input from the user's keyboard as the program's running, or we can use the command line arguments. We can use argc and argv to get information from the user before the program starts running. That's another thing we know how to do now. Our last option is read from a file that already exists. Let's read it, or a portion of it, into our program and use that to drive the way our program works. Okay? So this is very similar to OFstream/cin. It's just IFstream, right? It's going to be IFstream, and we're going to use this operator. And actually, the type of cin is iStream. It's not a file, so no F, but it's related just like OFstream and OStream. How cool is that? So yeah, let's talk about this. Again, cin is an iStream, and so is IFstream. Okay, both of those types are related in that way. And so let me remove all these underlines. Let's write a program that reads the first 5 integers inside a given file. I think we have a good one that we could read from right now. And then let's see what happens there. So let's assume the file has white space separated numbers like ours does. It's numbers separated between new lines. And then, yeah, let's take those 5 numbers, let's get them from the file, and maybe sum them together and print out the sum. That seems like a good thing to do. So let's do that. So let me show you how to use IFstreams to read a file. All right? And instead of doing the declaration and then open, I'm going to use this kind of syntax, this constructor-like syntax, to immediately open the file. All right? Let's do it that way. So sum, I guess we can call this sum.cpp, or let's call it ifstreams.cpp because that's where we're using them. So ifstream, and here I am going to, oh sorry, I'm getting ahead of myself. They're all in fstream, but the type we want is ifstream. I'll call it ifs, and the file that I want to open with my numbers in it is 1to10.txt. That's the one in my current directory. Alright, so now it's open. I gotta remember to close it as usual. Same with our output streams as our input streams. And yeah, let's read let's read 5 things from the file. Let's assume there's at least 5 numbers. We have 10. Let's read 5 of them and sum them together and print out that sum. Alright, so 4, int I is 0, I is less than 5, let's say, I plus plus, and then what we'll do is, instead of saying, like, here's how we normally get input, right? Like cin into a number n, we're going to replace this with IFS. Read from the file into the number in. Just the same. It's as if the user was typing the contents of the entire file. So then we have it, and let's add it to our sum. Sum plus equals n. Of course, I'm going to need a sum variable. Okay, sum plus equals n, and then we're done working with the file. We can close it, and then we can output the final sum. That looks good to me. So we're using IFS to read from the file. We opened it, and we read an int at a time. Space separated int at a time, and the first ints are 1, 2, 3, 4, 5, so let's figure out what the sum of that is. Drum roll, please. Apparently the sum of those first numbers are 15. Alright, so that is how you read from files using IF streams. Alright, let's see what else. What's my next example for us? I would like to do something fancy. I have a lot of words on this slide. Let's read it through and get started. So here is my idea. Let us read from an iStream until the file is over. Okay, let's figure out how to do that. I gave you the way of doing this on a lab, but I want to teach you the real reason why you can do that now. So we're going to read from an iStream, either CN or a file, as the condition of a loop. Let me show you what that means. So let me at least motivate this to you, because maybe you're getting a file from the user and you're not sure how long it is, right? Maybe there's 1,000,000 numbers, maybe there's just 100 numbers. The question is, how do you know when to stop reading? Right now, I have hard-coded, read 5 numbers, please. There's a better way than that. All right, so we can discover when the file is over. All right, an iStream object, for weird reasons, it can be automatically converted to a Boolean, and that Boolean tells you whether the file has been finished or not. Okay, so that means you can say something like this. You can put IFS in a condition, weirdly enough. It will convert IFS to a Boolean, just like it can convert numbers to true or false, right? Something similar is happening here, and the Boolean value that this gets converted to represents whether or not the file, IFS, is okay, for some sense of the word okay. Okay, it's true if it is okay, if it's able to continue being read from. Okay, that's one of the reasons that make it okay still. Okay, so IF streams, they stop being true or truthy once you've hit the end of them. Once you've tried to read past the end of the file, IFS becomes false, and that will stop you from reading if you keep checking, maybe as a loop. I hope that makes sense. So that is one way to do it. You can also check this. You can also say ifs.eof, which is a method that returns a Boolean. Let me go down to it. It's a method that returns a Boolean that tells us whether or not a special flag called EOF, which stands for end of file, has been set. Okay? So this will return true if the file has been read past the end. Okay? And that is definitely another time that you want to stop reading. Okay? So that is your alternative thing to do. I just prefer to put the IFS in a condition. But you can totally also use EOF. So with that, there is one last trick. You can put the IFS in a condition and also try and read from it at the same time. Read from IFS into something. You could make that whole thing a condition because this whole thing evaluates to just IFS once it does its work. And so it's as if you said just this, which again evaluates to true or false. And so this process, this idea of putting a read inside of a condition, will tell you if the read was successful. And so that's finally the pattern. This is why I've shown you this before with CN. This works. You can say while read a line from, or read a word from IFS or a number, whatever this type is, while you can do it, process it. Okay? This continues operating as long as this is a successful read, and it will allow you to read valid values only from an IF stream. That was a lot, but I think we're ready. Okay? So let me show this to you. Let's sum all the numbers in a file where we have no clue how many are in it. Okay, so let me show this to you. Read as condition.cpp. Let's call it something weird like that. So instead of, I'm going to steal most of this. And then we need Fstream again. But here's the idea. We're going to read as many ints as there are in the file. All the ints. And we're not sure how many there are, so it doesn't really make any sense to use a for loop. Let's use a while loop. And while, what I want to do is repeatedly read a number. That's the syntax. Repeatedly read a number as long as IFS is okay to be read from. And so this will evaluate to IFS itself, which will become true or false based on whether or not the file is over. All right, so yeah, that's the syntax. Read in from IFS in the condition of the loop, and every time you hit the body, that means this is still true. It was a successful read. Okay, so let me show you that, and it's going to work. Read as condition. It's going to read all 10 of those numbers in the file. Yeah, and so the sum from 1 to 10, I do believe, is 55, so that's perfect. It's reading all the numbers from our file, this one, and it is summing them. That's perfect. That's exactly what we want here. So the last thing I want to show you is that EOF is now set right here. So once you're done reading, ifs.eof gives back true because we've hit the end of the file. The file is now no longer okay. So cout ifs.eof. Maybe I'll say something like this, and I'll show it to you twice, actually. So at like the start of the program, EOF is false because we haven't read past the end of the file. We haven't tried to get to the end of the file. But you have this one. This is another option. Once you have read past the end of the file, EOF will become true. So that's another thing that could stop your loop. So see how it went from false to true? And we also have the correct sum. So that is reading as a condition. You could also have an infinite loop and just always check for EOF after you've read, something like that. All right, so yeah, let me give you one last thing to try. All right, I would like you to write a program that repeatedly gets a line from the user, so you can use getLine for that, and CN, of course, because that's how you know how to get stuff from the user repeatedly. And I want you to append that line, whatever the user gives you, to a file. Okay? So, are you ready? And I will try this for you as well after you have a little head start. So go try it, and then I'll come back and do it too. So we're going to repeatedly get a line from the user, and we're going to append that line to an existing file, or one that doesn't exist. It'll just start it off for us. Okay? So let's do that. That's going to require input and output. Input from CN, though, only. So, I don't know, get line and append or something. It's probably the easiest thing to write. Oops. So I need Fstreams. And we need the name of a file to write to, so it's going to be ofstream, right? And what's the name of the file we want to write to? I don't know, let's just call it like out.txt or something. And we're going to open it in append mode. So another way, it's as if you're saying .open here, you can give it to the constructor, iOS space, : app. So let's open up the file in append mode. Let's make sure to close it once we're done. And in the middle here, we're going to keep on getting lines from the user. So repeatedly get lines from the user and append that line to a file until I guess the user tells us they're done. Do we want a special value, maybe? Let's see. What's the best way to do it? Let's be like, while true. cout, enter a line, or like Q to quit. How about that? If the user types Q, we're done. And so now we can use get line and then cin line. I guess line can be in here if we want it to be. And as long as if line is equal to Q, then we're done, right? Then we can break. Otherwise, if the line wasn't Q, we're still here, and let's write that line to the file. To OFS. OFS, write to it. It starts off at the end now, wherever the end is of the file. And let's write the line. And I think getLine gets rid of the new line, so let's add it back. That seems to be the right thing, in my mind at least. So yeah, let's try running this. Let's see what's going to happen. Oops. C++ 17, getLine and append, -o, getLine and append. Boop. And so it's starting to write to a file called out.txt. It will make it if it doesn't exist, but if it does exist, it starts writing to the end of it, because we're in append mode. And now, let me write some stuff like, hello, world. I've just drawn a blank. What should I write? This is an example of OF streams and also of getLine, ... and then Q to break out of this loop. Don't write the Q to the file, but close it off. So what just happened was we took everything that the user gave us and appended it to a file, if that file already existed. It did not already exist, and so it just started a new one, and it wrote to it. Here's all the stuff that we wrote to it. Though, I could rerun it now. I could rerun this program, and like, here is more stuff. Extra lines. Q for quit. Now, we have appended. Isn't that neat? So rerun this program, it keeps writing to that file, appending if it's already there. So that, I think, is my last fancy example. GetLine and append. Okay? So, yeah, files aren't too bad. They're just like a new kind of cout or cin in a sense. You just got to remember the right types and the manner in which to open them if it's an OF stream. But the rest is kind of self-explanatory, which I hope is a nice breath of fresh air. So that is all that I want to say for this lecture. We'll come back and we'll talk more about files, and we'll do some cool stuff, like I'll have us edit image files. That'll be cool. But that's enough for now. So I will see you next week.